welcome to this video following a hydrogen...
Wait, lens cap was on.
God damn it, Willie. Hello, and welcome to this video following the hydrogen atom. My name is Shelby Copper, and I will be your guide on this journey today. Big Bang. We'll start by going back 13.8 billion years ago.
Woo!
We start deep in the darkness of space, back when there was nothing. The cosmos condensed very fast into small matter and then very quickly inflated, which became a big mix of electrons, quarks, and other particles. Then they rapidly cool and quarks clump into protons and neutrons. The electrons combine with protons and neutrons to form atoms, and then gravity makes hydrogen and helium gas to form giant clouds to form galaxies. As galaxies cluster under gravity, the first stars die and spew heavy elements into space to form planets. But today, we will be following the journey of one single hydrogen atom at the end of our program. Let's meet our hydrogen atom friend. Will?
No, Will Jr.
How does Will?
No, Will Jr.
How does Will Jr. specifically get made, you ask? Well, we have to look into what atoms are made of, subatomic particles, known as protons, neutrons, and electrons. Protons are subatomic particles that make up roughly half of an element's atomic mass, containing a positive charge. Neutrons are again a branch of subatomic particles that are contained within an atom and has a neutral charge. They can make up a majority of an atom, taking either half or more than half of an atom. In addition, an atom has one more type of subatomic particle known as an electron. An electron is so small that it has never been observed by the human eyes, yet we know they exist. An electron is a particle that carries negative charge and rotates around the nucleus in what is called the electron cloud. The electron is necessary to life as it is the fundamental cause of bonding with other elements, something we'll get to later. Protons and neutrons are made up of something called quarks. Quarks are subatomic particles carrying a fractional charge. When combined with each other, they make up the particles needed to make an atom. Electrons, however, are made of no such quarks and are regarded as fundamental particles. Now let's take a look at the atom. This is Mendeleev's model on how most people think of the atom, but actually it looks more like this. God damn it, Willie. Let's cut to the graphic. This here is a hydrogen atom, which is made up of one proton and neutron in the nucleus and one electron. As you can see, the electrons do not rotate so cleanly in this model as they do in our original drawing, the most common error in the atom model. The electron on the outside is not actually rotating in a perfect circle, but is located on the first energy level, kept inside its own orbital.
Look, Shelby, there's protons on the floor.
Yes, Will, that's right. Protons are everywhere.
No, there's actually protons on the floor.
Next we have on our list of information is isotopes. Isotopes are each of two or more forms of the same element that contain equal number of protons but different number of neutrons in their nuclei, and hence differ in relative atomic mass but not in chemical properties. In particular, a radioactive form of an element. Hydrogen has three naturally occurring isotopes: protium, deuterium, and tritium. Being that atoms are so small, our understanding of them is limited in many ways. For example, due to the incredibly low mass of atoms, like hydrogen and helium, it is near impossible to use today's technologies to separate them from experiments, meaning in what are supposed to be fully controlled tests. Traces of hydrogen can be present in samples. For that reason, a new process called isotopic labeling can possibly be used to follow isotopes of elements and distinguish atoms from one another. Fusing! Nuclear fusion is the process of making a single heavy nucleus from two lighter nuclei. This process is called a nuclear reaction. It releases a large amount of energy. The nucleus made by fusion is heavier than either of the starting nuclei. However, it is not as heavy as the combination of the original mass of the starting atoms. This lost mass is changed into lots of energy. This is actually where Einstein's famous E equals mc squared equation plays a part.
Hey Shelby, do you and your friends want some cookies?
I know I do.
Elements are also no longer up to the governing of nature. A particle accelerator, also called an atom smasher, is a machine that makes particles travel at very high speeds. Accelerators work by pushing particles like electrons, protons, or nuclei with electric fields by steering them with magnetic fields, and by smashing these particles for brief moments, new atoms can be created.
Spectroscopy. Brought to you by Noah's Bagels.
Pick a pack of poppers.
Spectroscopy is the technique of element observation of telling what elements are what. The color or the emission spectrum of a chemical element or compound in the spectrum of frequency electromagnetic radiation emitted due to an atom or molecule making a transition from a high energy state to a low energy state. Each element's emission spectrum is unique. Therefore, spectroscopy can be used to identify the element in matter of unknown composition.
My bad.
Each element's emission spectrum is unique. Well, that's the old cards.
Oh, my bad.
So when an electron jumps from one high level to a lower level, or vice versa, a color is emitted. Every element has its own individual color spectrum, so certain colors coincide very specifically with an individual element, meaning large explosions or presence of certain colors in space allow scientists to see what type of element is making such a light.
Electron jump, electron jump, electron
Oh,
jump.
well.
Electron jump.
Scientists can use these spectroscopy machines like these to monitor these chemical changes with advanced sensors to automatically identify the exact type of chemical change. On the far left of the periodic table are the alkali metals, and on the far right are the noble gases. They have a complete outer electron shell. Although hydrogen is in the column of the alkali metals, it is not considered to be an alkali metal. The alkali metals are group 1, and this includes lithium, sodium, potassium, cesium, and francium. The alkali metals have 1 electron in their outermost energy level. The alkali metals are the most reactive of all the metals. The alkali earth metals are the second group on the periodic table. They consist of beryllium, magnesium, calcium, strontium, and radium. Group 18 on the periodic table is known as the noble gases. They are generally chemically inert. This means that they do not react with other elements because they have the desired total electrons in their outermost energy level. The electrons in this group are helium, neon, argon, krypton, xenon, and radon, and are monatomic gases. Only helium and neon are truly inert noble gases. Group 17 is the halogens, which means salt form. The halogens form salts when they are reacted with metal. Halogens exist in a variety of states. At room temperature, fluorine and chlorine are gases, bromine is a liquid, and iodine and aspartame are solids. All these elements exist as dynamic molecules in the gaseous state. This means that 2 molecules form together to form molecules of the gas. This form of elements form bonds with alkali metals because there is 1 electron short of having a complete outer shell. Some flaws in the table are that the elements that bond with each other are on opposite ends of the table, so it doesn't show the connection between them. Some other flaws is that there is a separate island of elements known as the lanthanides that should be part of the graph, removed only because of how long the table would be if it wasn't. There are 2 types of bonding, ionic and covalent bonding. Ionic is the attraction between positive and negative ions. Hydrogen bonds with itself to complete its outer shell. It is also the universal bonding. Covalent bonding is chemical bonds between 2 nonmetal atoms. As they are both nonmetals, which means that they need to gain electrons, they have to share, so their outer shell crosses over in order to have a full outer shell. A full outer shell has 8 electrons. The electrons in this outer shell are called valence electrons. As example of hydrogen bond would be hydrogen and oxygen bonding to create the compound of water. Will, you're supposed to splash the water at me.
Oh hey, welcome back to another Side Notes with Will. Hydrogen. If it's on a spelling test, you're not going to spell that correctly, so let's review. It goes H-Y-D-O-R-G-E-N.
Well, it's spelled wrong.
We'll see you next time.
Hydrogen does not react with dilute gases or bases. Mixtures of hydrogen do not react unless ignited with a flame or a spark, and which results in a flame or an explosion. Hydrogen bonds are relatively strong, and when hydrogen is reacted with transition metals, it makes the metallic hydrides. The element frequently participates in chemical reactions but is unreactive under room temperature. It is only reactive when heated. Now we'll get to the journey of our atom.
Oh hey, welcome to our second edition of Side Notes with Will. Here with my special guest, Nolan Copper.
Will, it's not that time, and Nolan, get out of here.
We'll see you next time on Side Notes with Will.
Our atom, Will, was first made as part of the Big Cloud after the Big Bang. In the fusion process of hydrogen, as the nucleus of deuterium, 2 hydrogen forms from 2 protons with the emission of an anti-electron and a neutrino. This big cloud makes galaxies, and in those galaxies there were stars, one of which contains our atom, Will. The amount of energy in those atoms creating the fusion processes create color in the form of light that reaches far into the galaxy. The lights given off by hydrogen are red, blue-green, blue-violet, and violet. These colors show the amount of energy that hydrogen has. One day, the star that houses our atom will and has lived past its expiration date and explodes into a supernova, moving at speeds never before reached by humans. Our atom will is thrusting into the vastness of space, escaping the gravitational pull of celestial bodies, will finally find itself in ice-covered comet. Thousands of years later, our comet containing our hitchhiking will hits the surface of planet Earth, landing in what would become present-day England. Thousands of years later, combining with hydrogen atoms floating throughout the atmosphere, recognized as a discrete substance, Henry Cavendish notices the element and finds out that hydrogen is a specific element and substance. Research throughout the years discovers that hydrogen is located in the alkali metal region of the periodic table, but isn't actually an alkali metal. Hydrogen and helium are themselves the first elements to the periodic table. Hydrogen is the universal bonding element. It has one electron on its outer shell and can combine with almost any other element. Finally, released back into existence, will, our element, could have possibly been breathed into your lungs by anybody here.
We'll see you next time.